Thank you so much for coming. So today we'll continue, all right, in Python. And so what we are covering today we're going to cover the network programming, this lecture and next lecture. Then we're going to talk about web clients and servers, and then we're going to talk about CGI, and we might delve into Django if we have time. So these two lectures, this lecture, next lecture, are for these topics. Okay, we'll cover as much as we can, and the rest that you have to pick up by yourself. I include some application, some programs, which included in the files on the PowerPoint. Let me just get some of the lights off. Okay. And you'll see the PowerPoint on Canvas today, if it's not there already. All right? All right. So let's talk about network programming. I mean, in the network programming, usually, we have in the computer, in any computer, a PC for example, okay, we have a memory, we have a CPU, I'm not sure why I'm doing it so small. Okay, in any computer. Okay, so you have memory, CPU, central processing unit, and you have I/O, input output, right? All right. The input could be a keyboard. The output could be screen. Okay. All right. So what we run in the memory, and we have, of course, like the hard memory, the hard disk, for example. Okay, hard disk drive. All right. So usually what we have a code, right? When executed, we load it in the memory. What we are creating? Process, right? Right? Process. Multiple processes are running. So the processes, what they are using, what the resources for the processes, the memory and the CPU. All right? CPU. Now, so we have something called inter-process communication. So you could have multiple processes are communicating. Communicating what? Data. Data. So you have, for example, you could have process one, for example, produce the data, and we'll move it to process two, to process two. Let's say process two do sorting for the data, or analyzing for the data, right? So if it's in the same computer, okay, the communication will be easier, right? There's a different way in communication, and when you take Unix systems programming, okay, right? You'll learn about the difference. So you could communicate with byte, for example. You could communicate with a shared file. So, for example, there is a shared file, and I'm just giving you the basic things in here. So this is a process, when it needs to share the data with the process 2, it puts it where? In the file. And process 2 reads it from where? From the shared file. All right? From the shared file. Or it could have a pipe. Or it could communicate inter-process, communicate through sockets. Anybody heard about sockets before? Create a socket, right? All right? So you could create a socket. What is a socket? What is this in here? If it is a phone jack, it's a socket, right? So if you need to communicate with the phone, you have to plug your phone to the socket. That means you plugged it to where? To the network. And the data could move from this computer to the other computer. So far we are talking about communication within the same computer. What if we have another computer? So this is computer 1, this is computer 2. And we have process 1, or a group of processes, okay, run in computer 1, and process 2, for example, runs in the computer 2. And we need to exchange the information. So we have to find a way that we join these computers, okay, and have the data move from process 1 in computer 1 to process 2 in computer 2, right? That we call it sockets, right? Socket creating a socket. Right? All right? So that's what is inter-process communication.
So you mean the socket is like not an inter-process, it's like an external process?
It could be intra, it could be enter. It could be intra, it could be enter, right? All right, so you using, for example, C, C++, Python, Java, you could create this kind of communication, inter-process communication, or intra-process communication, all right, by creating a socket. So we're gonna see how it's done. We're gonna give you a background. So I added some background to the topic in case some of you did not have any previous knowledge about it. And we'll take a couple of programs to see how we can do it with Python. That's what we're gonna cover in this section. Clear? Okay? So it's the communication between processes. Process, right? Process, right. Okay. So, all right. So also, before I go, most of the applications, that we cover, or we know, okay, it's like a client-server applications, right? So for example, all right, the web server, if you have a batch web server, or IS, internet, okay, or Apache or whatever, okay, server, web server, let's call it web server. Okay, and you have like a browser, let's say if, what you use, Chrome, all right, or Explorer, whatever, okay, browser. Okay, whatever the browser. So, in the web server, what you have? You have the data, you have, for example, the web server, for example, CNN.com, right? Okay, you come in the browser, HTTP, CNN.com. Okay, this is the client. It will send a request to the server for the data, and the data will be sent back to the client from the server, client-server application. So many of the applications we have nowadays are client-server applications. Web server is one of the applications. Printer servers is one of the applications. All right? If you go, for example, DHCP is one of the applications. DNS is one of the applications. So many applications, client-server applications. All right? So this is like the module, database, adding a database server. So when you access it from another machine, this machine is client-server application. All right? So most of your work nowadays, big projects, you gotta use client-server applications. All right? So I think I added enough background for those people who did not, so I'll try to cover as much as I can. But as I told you, I cannot go over everything, so we know what's a server, right? Okay. By now we know, okay, just a second. Let me do this one, like that. And span, so server, which is a piece of hardware or software. So the server could be a hardware or software, which provides a service that is needed by clients. All right. When you talk about a printer server is a software on a machine. All right. So when you try to access a printer, what do? You send the job to where? To the printer server, and the printer server sends it to where? To the printer. All right. To provide a service. So the client will wait. the server will wait for the client to request, so the client will request some service from the server. So look in here, for example, you have in here a server, okay, and you have a client. All of them are interconnected by the internet, all right? So the request will go from the client to the server, and the server will respond with the service requested, all right, with the service requested. So if this is a web server, if the server is a web server, okay, and in here, the client asks for CNN.com. They say this is a CNN web server. It will get you the information from CNN. You know, today is elections day, is a vote day, so my brain is with CNN, with Fox, not Fox, CNN, all right? And anyways, so if I keep mentioning CNN too much in this section, in this class, you might. All right, so there is hardware. As I said, the client server could be hardware. So the printer server is an example. File server is another example. File server. Like for example, the Google Drive, when you access your files. So you are from your computer, it's a client. Where is the data saved? In the file server. So you could request your okay. If you have used NFS in some systems, okay, network file system. Okay, so this is kind of hardware. There is also software client server architecture. All right. A big example for that we use every day is the web servers, the database servers, the Windows servers. All of these are examples of software client server architecture. All right, so what we need to do, we need to communicate data. So the client will request data from the server, and the server will provide the data or the surface, whatever the server surface is. So there is a communication endpoint, okay, created at the server. So what does the server do? The server, the server to provide a service. What does it do? Okay, it will listen. Okay, the server. Okay, it will. Its job is to listen for the request from the client. All right. Then you have the client. Whenever it needs a service, it will go and ask for the service from the server. Okay, it keeps listening. The server keeps listening until the request comes. When the request comes, it will provide the service. So the server in the client server model, what is its job? Listening for the request. When the request comes, it will serve the request. It will serve the request, right?
It is always about listening.
Huh?
It is always listening.
Always listening. Once you start the server, it will be always listening.
It doesn't depend on the protocol the server is running.
Like what? Like for example, if you have a printer server, okay, so the printer server, you start the printer server in your computer, what does it do? Keep listening. Listening for what? For the request to print, right? So the server, it will be listening, okay? If it's not listening, then it's not a server. Right? It will be listening, right? All right, so all a client has to do is to create a single communication endpoint and then establish connection with the server. Establish the connection with the server. The client can now make a request, okay, for exchanging the data. A client, so who starts the request? The client. Who provides the servers? The server, which is listening all the time. So once the request has been processed and the client has received the result, okay, or acknowledgement, then the communication will be terminated. So that means that when the client needs a surface from a server, the first thing has to do is connect. Then the data exchange happens. Once the data exchange happens, then it will disconnect. All right? Disconnect. All right? So there's different ways for this kind of client servers, but the most common one is a socket. The socket communication endpoints. So sockets are computer networking data structure that embody the concept of communication endpoint. Embodies the communication endpoints. Anyways, sockets, it's a long story. It has been for many years, and initially was in the same host. So you have sockets in the same host, okay? But the communication now between what? A client and a server in the same host. When you talk about host, what is a host? Machine, a computer, the same computer, right? All right? And that's what we called it at that time, inter-process communication. Inter-process communication. So there's two types of sockets. There's two types of sockets. There is file-based and there is network-oriented. So network-oriented, that means a communication over the network. File is by sharing the data over files. It's a very simple step, right? And Python supports some of the families. There is so many families for sockets, but it will support AF. What does AF stand for? Address family. Address family. So the basic one is address family Unix, then address family netlink, transparent IPC, inter-process communication, and for IP6 it will use init6. Anyways, so in the file-based, the family name usually is the AF Unix or local, and these are both supported by Python. Okay, it supports AF underscore Unix for backward compatibility. And also there is a network based. When you talk about network, what does it mean network? That means the data will communicate over TCP/IP, right? Over TCP/IP communication. You know what is IP, right?
Yep.
Internet Protocol. And you know what's TCP? Okay? You know where both work, right? So anybody took DCC from before, and that's why it's a very important, truly, to have enough background about network when you talk about this, right? So, if you recall that usually you have 7 layers in the communication, OSI reference model, right? So the first one is
Physical. Network.
Data link.
Network. Transport. Session, presentation, application.
Transport. And this I call it application. The 3 of them, I call them application. Okay. So what is the most famous in the, in the network?
Routing
the
protocols.
IP, right? IP protocol in here, TCP and
UDP.
UDP, right? All right. And of course, in data lake there is different protocols, and the application there's many protocols. Okay, Telnet, FTP, whatever, all the applications. All right. So in the network, the communication is happening over IP, over TCP/IP. All right. From your background in TCP/IP, we call it TCP/IP. Why we call it TCP/IP?
Because it's a secured connection.
So when you say TCP/IP, what does it mean TCP/IP? It's a protocol stack. So it's kind of picked up the two most important protocols running on this scheme, and they name the architecture out of it, TCP IP. Okay? All right? So what is TCP? It's a transport protocol. Okay? What is the difference between TCP and UDP? This is
Connection oriented, connection.
oriented, right? And this is connectionless, right? How about IP? Connection or connectionless?
It's connection.
What? Connectionless, right? Protocol. So what is the difference between connection oriented, anybody knows, and connectionless?
Let's use synchronization. Like you have to synchronize between the two, like the server and the client. There should be like some synchronization for connection, and for the UDP, it doesn't need any synchronization.
Alright. So in connection oriented, okay, what you have to do, first you have to establish a connection. You have 3 steps. Connect, send, disconnect. So the first step you have to do, connection. Alright? In connectionless from the name, what does it mean? There is no connection, you don't have to establish. Okay? What is real life example for connection oriented? Like the mail system, right? So, when I need to send you a mail, do I have to tell you that I'm sending you a mail? Do I have to connect with you? No. I don't. I write the mail, put it in the mailbox, right? How about the connection is like what?
Video stream.
Like what?
Video stream for UDP.
Like the phone, right? Okay. If I need to call you, what I have to do before if I need to tell this gentlewoman, okay, is it work, gentlewoman? It works. Let's say handsome woman, whatever. Okay, nice person here. Okay, if I need to tell her there is no class next week, so I have 2 ways of communication. Connectionless. What is connectionless? Mail. Send her a mail. All right. Or connection oriented. What does it connection oriented like for? So I have to bring her. I have to call her number. What is this? Connect. Then she says hello. I said hi. There is no class next week. Oh really? Thank you. Hang up. Disconnect. Right? So which one is better? Connectionless or connection oriented?
Depends upon the application.
Like in terms of, like connectionless is fast.
Connectionless is guaranteed.
But connection is guaranteed.
Connectionless is faster, but connection oriented is guaranteed. Why is guaranteed? Because I will know for sure she got the message. I connected first, then she accepted the connection, then I told her the information, then disconnect. So which one is more reliable, the phone or the mail? The phone. That's why we say reliable communication. There's a difference between connection oriented and connected, right? All right?
In the board.
What?
You have to switch the mail for the connection. And then the phone for the connection.
The mail, yeah. Did I do? Okay. All right. So the connection is like the mail, and this like the phone, right? Okay. So that's what it is, right? So in sockets you could have both. You could have UDP and you could have TCP. You could have both UDP and TCP. Now the question, which one is better? Reliable communication or not reliable communication?
Depends upon application.
Depends on the application. Depends on the application. All right. So for example, for video streaming, we use usually UDP connectionless. Okay. For different. Anyways, this is off topic. All right. But it's very important to realize what's happening in here. All right. Okay. So network-based socket. So there is different address families. There is INET. The first INET, address family, internet, which is the most widely used. There is INET 6, which is used for IP6. By the way, I started myself teaching DCC in 1997. How many years ago?
21.
21 years ago. And every time I teach it, I said in 1 or 2 years, the only IP we're gonna use is IP version 6. 4 will be gone. Until today, 4 is the one used, the 6 is the rare one. All right? So few years ago, I stopped saying that we're gonna have IP6, you know. Okay. But anyways, both are available, but most of the networks, as an example in UP, we use IP4 still, right? So IP6 is for Internet Protocol version 6. There is also IP. Today we're going to have example about this only. There is address family called netlink family for connectionless socket, which allows inter-process communication between user and kernel level code. All right. And there is something called also a transparent inter-process communication, which allows clusters of computers to talk to each other without using IP-based addresses. So we are not going to talk about this or this or this. Today we're going to talk only about this.
Sorry.
All right. So, so you understand what we're talking about, right? We're talking about creating a socket for communication between two processes, whether they are in the same computer, same host, or in two different hosts, or in different hosts, right? Okay? And we don't care about the file socket, we care about internet socket, network socket, right? Communication, right? So if a socket is like a telephone jack, and that's why we call a socket. So the socket is like a telephone jack, okay? A piece of infrastructure that enables communication, then host name and the port numbers are like the area code and the phone number. So to be able to communicate, we have to have a socket. Think about it like a phone jack. And then we have to have what? Address. Okay? By the way, in Ethernet or in the network, how many levels of addresses we have?
2.
How many levels of addresses we have?
2.
2?
Physical and...
Who says 3? Who says 4?
2.
2. I have no $5 to donate, okay? One of you still need $5 from me. Okay?
Sender.
Who says 1? No one. Who says 2? Okay. Who says 3? Nobody says 3? Nobody says 3? Seriously?
3.
Can you please say 3? 3? You're correct. So the question, what are the 3 addresses?
Sender, receiver.
What?
The physical.
There's the physical address. We call it the MAC, the physical or MAC address. You remember the MAC address? And there is the IP address. Okay? And there is a port.
Port is not an
Which
address.
is the transport address. The port, yes, is an address. Right? When application communicating with application. So communicating with IP address and the port. What is the default port address for any web server?
80.
80. Could you change it?
No. I mean,
What do you mean no?
yeah.
Yeah.
Yes.
Could be 88, it could be right. Okay. So it's address or not address.
Yes.
If you go in your web server, okay, and you change the default to be 8080, for example, 8080. And let's say Abu's name. I have a website. I have a website called abunaid.org, right? The default, if I made the default 80, right? Okay. If I try to access it without putting the port, it will not access, because now the port is part of the address. All right. So, anyways, there are 3 levels of addresses, right? So, what is the MAC address?
Medium access.
medium access. I mean, used for transferring files and stuff. Usually.
It's the same as an Ethernet
No,
address?
no.
No,
It's not?
It's like hardware address.
Hardware address. It's not the
Just like a
Ethernet
name.
address?
Just like a name.
It's the device address, address of the particular device.
All right. So, can I call it Ethernet address or I cannot? That's a
No.
question. Yes or no?
No.
No,
Yes. Can I call it MAC address or no? Yes. Can I call it hardware address? Yes or no? Yes. All right. Okay, which one is the most correct name?
Mac.
Maybe hardware address for me, but definitely not the Ethernet. Okay, why we call it Ethernet address? What is Ethernet? We are off topic now.
It's not like internet and like I don't know what to explain. It's like interconnection inside like in hardware level.
Sure. Ethernet is a technology called Ethernet. All right. So when we start having a network, we have Ethernet. We have something called token bus, token ring, different technologies. All right. But which one became the most dominant? Ethernet. So I'll give you another example. When I tell somebody, can you make a Xerox? What's a Xerox?
Scanner, printer.
Huh?
A Xerox printer.
What is Xerox?
It's a name of a
It's the name of a company.
company, not the
But
photocopy.
because it was the most common company at that time, the first one, okay, give me a Xerox. What is a Xerox? The name of the company.
Yeah, exactly.
Okay, even if the
photocopy.
name of the copy machine is a different company, what do we call it? Xerox
Xerox.
machine. Why? Because. Another example, when I tell you, give me Kleenex. Kleenex. Kleenex tissue.
Tissue,
Tissue. I mean, where I come from. I mean, they don't tell me, we don't say give me a tissue, give me a Kleenex. What's a Kleenex?
It's the name.
Is a company that produced the first tissues. So in many places in the world, tissue is equal to Kleenex, like Xerox, like Ethernet. So Ethernet is one kind of the network cards called Ethernet, but it's not the only one. But because it became the dominant, we call it Ethernet. All right. So when you say Ethernet is correct and wrong, it's correct because mostly now in the laptops we have Ethernet. All right. Right. So this is a laptop in here. Okay. That's an Ethernet. This is RJ45 connected to Ethernet. All right. But 20, 30 years, Ethernet was not only. Now is the most thing is the Ethernet, right? Okay. And we call it hardware address. Why is it hardware address?
Because it resides in the it's like internet card, right?
Because it's engraved, printed on the network card. So you cannot change the address. Okay, so each Ethernet card you buy in the whole world has a unique address engraved inside it. You cannot change it. How about the IP address? Can you change it?
Yes.
Yeah.
You can change it, right? It's not the hardware address. It's not the hard address, right? How about the port? Can you change it? Yes. Can you change it and all of that? Anyways, off topic, off topic, off topic. Okay. All right. All right, so we understand what we are talking about. It's very important, right? So the internet access is comprised of host name and the port number. Host name is equal to what? To the IP address, right? Okay. Again, what's the host name? it's the IP address, okay? And host name could be the DNS name, right?
Device.
All right, DNS name, right? And I'm gonna explain this. Okay, so there is port numbers. So the port numbers, how many port numbers are there?
So many.
64K. 64K. 64,000. So it's from 0 until 65,535. 64K, right? Okay, but usually less than 1K are used. 1K used. But you know, you're free to use any number of these you know, okay. So if you would like to take a look, there is I provided a link for you for the most common port numbers. So for example, 21 is a port for what? 22 port for what?
FTP,
Huh?
file transfer protocol.
22?
Think so.
How about SSL?
This is so.
Oh, it's a TCP UDP port.
Right, if you take a look at this, the official side, so which one I asked for?
SSL.
So 21 is a file transfer protocol, right? Okay. 23 is a telnet, all right? Telnet, and there is 23 for TCP and 23 for UDP, of course, right? How about SSH?
22.
30,
22.
22. Okay, SSH is 22, right? So these are the assigned ports. So that means there are some famous ports assigned for certain protocols. You should not use them. So for example, if you have a web server, the default is 80, right? Don't make it 23, because if you make it 23, then you are conflicting with Telnet, for example. Okay, so these are the most, anyways, I provided the link for you and you could search it further. Alright. So we spoke about, I already explained what's connection-oriented sockets and connectionless, okay? So connection must be established. In connection-oriented, the connection must be established. You agree? The connection must be established, okay, before communication. It's like virtual circuit and or stream socket. You know what's virtual circuit, right? And datagram and all of that. I think you already covered that in DCC anyways. All right, so it's a reliable, you're gonna have a sequence of data. So you have a message, the message could be divided into,
I'm sorry.
into,
What is your question?
by the way, I mean, I turned the light. Because I turned the lights off there, nobody talks to me. But you are very active because, now let me see it. Let me see the experiment in here. Okay? So, what was the question?
It's split up into.
Now I have the light too. What was the question? Simple question. What was the question? I remember when I was in the school, okay, the teacher asked, I mean, by the way, as far as I know, it's good to make interactive interactive session, ask people, and you don't mean when you ask some person that you to belittle him and all of that, because you could ask me a question, and my answer would be, I don't know. Simple. All right? I'm not supposed to know everything. And it happened many times to me that people ask me a question, I don't know, but I'll get you the answer next time. There's nothing wrong with it. All right? What's wrong sometimes if you come to a class and you don't pay attention? Don't waste your time, right? You have to pay attention. So I remember when one of the school years, when I was at school, the teacher asked the student colleague, okay, a question. First question. He could not answer. Then asked him a second question, could not answer. Third question, could not answer. Then he asked him the fourth question. He said, ask yourself a question and answer. So that's, just ask yourself a question and then answer. He said, no. Okay, so he could not even ask himself a question and answer. All right, so I'm asking a question. What was the last question? Can't be any simpler question. You don't have to answer it, but at least you have to listen to me. What was the question? So what was the question? What was the question? The message divided into packets. That's the answer, packets, right? Why? Remember, okay, now, from your DCC, who did not take DCC, data computer communication? You never took it? No. Okay, I'm very sorry. All right, so why we don't send the message as it is? Because the message could be big, very big. Imagine that you're sending a file, a video, which is 1 gig bytes. All right? So it's impossible to send it. So what do? You divide it into packets. And they give the packets a sequence number. And you send them. Is there a guarantee that will be delivered in order?
May or
No. Is that a problem?
no.
Why? Because we have a sequence number. So the receiver will sort them back, right? So we divide the data into the message into, we break it into multiple pieces, we call it packets, and we'll try to have it guaranteed. So the primary protocol used is TCP, which is a reliable protocol, okay, and the socket type is sock stream or socket stream, all right? And that's what we use for init protocol using the IP. We're talking here about what? Connection oriented, and I'm sure you are expert now. What is connection oriented? Connection oriented like what? Mail or phone? Like phone, right? Then you have connectionless sockets, okay? And in connectionless sockets, we send datagrams. All right? All right, so it will use socket datagram and UDP, not TCP. It's gonna use UDP, which is connectionless, all right? All right, now we come to the programming. That was a background. So programming in Python, when you talk about programming, we talk about modules created for you and you use, right? Okay, so the module that you're gonna use for that is called socket module function, okay? Where you can create a socket, okay? To create each module is built of, come on guys, the modules in Python are built of classes, and the classes have methods, all right? So to create a socket, the first thing for communication, the first step is to create a socket. So there is a socket method, part of the socket class. All right, we're gonna take example right now. So that's how it looks. Look in here. That's how it looks. Socket. So the first thing you have to tell the socket family, then the socket type, and the protocol by default is 0. All right. So the socket family, you have two options, either the AF Unix or AF init. Which one we're gonna use in here? The network, right? The network one. And the socket type, it could be socket stream. Stream for what? For connection oriented. And could be datagram for what? For connections. All right? So let's take example to create a TCP IP socket. Okay, we need to call the socket. So socket in here, socket, and we call the method socket. The first parameter is what? In here, what is it? The socket family. What is the family? In it. And then here what we have?
Socket string.
The second type. What is the type? Is a connection oriented. All right. For UDP, the same thing, but we pass the data graph. It's just a function. A function. The function has how many parameters?
3.
3. 2 you must pass, and 1 is?
Default 3.
There's a default. You could change it, but there's a default. All right? So, by default, how many parameters you have to pass?
2.
2. Because the third is as a parameter. All right. So, basically, we're going to use a from socket, import everything, or put asterisk. All right? So, example. That's a good example in here. Okay? Socket. And the 2 parameters passed are what? The first one is the
socket family.
Socket, and then the type, which is TCP. All right? And it will return some value in here. So there is multiple functions that it comes with the socket. Socket what? Class. The first one is bind. So after you create the socket, what you have to do?
Bind.
To bind. Bind what?
Address.
Address to the socket. Alright? You have a phone jack in here. What is a phone jack? Socket. You have to bind something for it. What do you bind to it? Phone number. Phone number. Phone number is built of 2 parts. What are the parts?
Area code.
Area code and?
Extension number.
Okay. Same thing in here. We have the socket. What is a socket? It is a device for connection. We have to bind an address for it. The address has 2 parts. What are the 2 parts?
A
Host and host name or IP address. Okay? So bind address, host name, and the port number pair to the socket. Then after that, we agreed that what is the function of the server? Listen. So first of all, I created the socket. Step number 2, I bind the address to the socket. Number 3, I'll make it listen. I'll tell it listen. Now you are ready? Just listen. How it listens. Just holds the ear like this. And listens to the clients to come. Okay? Now if the client requests a surface, what does it have to do? Accept. It does accept. That's the 4th step, right? So this is at the server socket. At the client socket, what's the first thing it has to do? Connect. Connect to where? To the server. Server, what does it do?
Accept the connection or reject it.
Before connection to it. It has to be doing what?
Listen.
Listening. Lights worked. Listening, right? It will be listening, right? Alright? Or you could have connect underscore EX, which is extended version of connect, where problems returned as error codes rather than exceptions. Okay? And there's many other now. So this is for this part in here is for the server socket. This is for the client socket, right? And there is many common other methods. I'm not sure if it's readable for you. So the first one, for example, is receive. What does it do? Receive TCP message. The next one, receive info. Then the third one, send. What does send? Transmit TCP message. Send all, etc., etc., right? Alright? And there is many other functions. As I told you, and here we're covering just introduction to the socket. But if you really have a massive application that uses socket, you really have to know what are all of these methods, which one that is useful for your application, how it works, and all of that. Alright? I'll skip this.
Do we have to know this for the final?
What?
All this method, do we have to know them for the final?
You have to know them in the final?
For
Yeah.
the final.
Yes, please. I'll be more than happy if you know them.
I mean,
Alright.
are you asking,
Huh?
are you gonna ask about, like,
I hope so.
You're not.
Professor, in socket we have 3 parameters, right? The last parameter protocol, what is the role of that? We are, in the second parameter itself, we are saying is that connectionless or
Sure.
connection oriented, where
Yes.
it is TCP or UDP protocol, we are saying there itself. So what is the role of protocol?
The last parameter, the third parameter,
Yep.
the answer I don't know. Okay, and I really don't know. All right, but we could find out. All right. So file-oriented socket programming and the data attributes. Just take a look at them. I don't want to waste time. So that's how these are the steps. These are the steps for creating TCP server. What is the first step?
Create a socket.
Creating the socket using the socket function. Then I save it SSS. So what's the name of the socket?
SS.
SSS. You could name it anything. And after that, what you do?
Bind.
You bind an address to it. Then you make it listen. Then you have 2 loops. The first loop, okay, loops, and they are infinite loop. The first loop, what does it do?
It accepts.
Accept requests from client. Once it accepts a request from client, what does it do? Then it does the communication loop. Why are we gonna have a communication loop? Because you have a message divided into packets. You're gonna send packet 1, packet 2, packet 3 until the end. So there is loop inside that loop. Then after that, what we have to do? We have to close the client, this client socket, and then close the server socket, which is optional. All right, and then good, right?
So the client socket is made when through the server socket.
When you yeah, well, no, the client socket is made through the client. But how you close it?
But
When you send an empty packet, you're telling the client to close your connection.
so CS is equal to ss.accept. Does accept return a socket?
When it accepts, it will communicate with the client, tell them the communication is accepted. So after the accept, what does it do? It's gonna go to the receive send. It will gonna send something to the client, right?
Yeah.
So the client, when it receives the first message or the first packet, it knows the request was accepted.
Yeah.
All right,
Okay.
and it will send it to where?
The client.
To the address of the client and the port of the client.
Okay.
Right? We'll look in here, before here, no. I thought I have the same thing right here. So look at the client in here. The client, what does it do? The client also creates the socket. Okay? And then you bind, and then you connect. You connect to where? To the server. Connect to the server, attempt the server connection. So how do you connect to the server? Using the IP address and the port of the server. You have to know it. Okay? Right? Connect, right? Then after you loop in the client, why you looping? Your communication loop. Okay? So sometimes, mostly the data will be sent from the server to the client and from the client to the server.
But first, the client's socket is the one created.
What?
Like the client's socket is the one created first. Because
No, the server socket is created first. So you have to create the server socket, you have to bind an address for it, and then you have to make it listen. And it will stay like this forever. Now clients, okay, will create the socket and then connect to a known server socket. All right? So I am now a server. I'm a socket. I'm a server, right? What's my name? What's my address? Dr. Abu's name. All of you is what? Clients. All of you clients, right? So to be able to communicate with me, what I have to do?
Except,
I have to be listening, right? I have to create myself, I'll be listening to you, right? Listening to you. Okay, then, you know, I'm telling you, I'm a socket, and my name, if you need to ask me a question, call me Professor. What's my address now? Professor. What are you? Client. If you need to connect, what do you do?
I create a socket.
To where? To my address, which is Professor.
So my client's socket will have your address.
Exactly. Okay, you're gonna connect with me.
We can use for multiple clients.
You can use multiple clients, yes, of course. All right? So the question is, if there is an IP address and port of me, all right? If one client communicating with this port address, it will be channeled, right? Right? So the question, if somebody else tries to communicate at the same time, how we can communicate with two people? How can I communicate with two people at the same time?
Create another socket. You create another socket.
No, I'm a server. I have one socket. So there is a major. Okay, let me give example. So for example, if you call the main number of UB, right? Main number of UB. What does it do? Transfer you to
Help desk.
inter number. So that's what will happen. When you communicate with me, you call me with the main number, the main address. Then after that, I'll give you a temporary address. So let's say there's 5 clients trying to communicate with me. They will connect with me with the main socket address. Then I'll give you a temporary. After that, we have a temporary port we're communicating. Then he communicates with me. Then I give him a different temporary port. So I could have like 5 or 10 or 2,000 communications at the same time, but with what?
Different.
Different ports. Different ports. Clear?
Yes, it's clear for the client side, but it's not clear for the server side. Like, because you're the server, you have to create like different sockets for each client.
No. One socket.
One socket, but for the same IP address, you're giving different.
Same IP address, different ports.
But they're a different client, they have different IP address. They are like different clients, so each client has a different IP
Sure.
address.
But I have one socket with a main number. After the establishment, we'll have communication with a different port. Just one socket.
Okay, I understand that each client will have like one socket for the, like almost like the same socket for the server, right? But different ports for each, for each
Client.
socket, like, but the server one, so like the server sockets. Like you'll have like this client, host name and port, and then to communicate with another client, he has to have like another socket with like a different name, host name and then port. Right?
It's one socket. It's one socket created, okay? But the communication will be with the same IP address, main IP address, but different port numbers. So we don't call it multiple sockets.
Okay.
It's one socket.
Okay. It's
Maybe
one socket.
when we run some code, it will be much more clear.
Professor, do we use multi-threading here?
What?
Do we use multi-threading of this?
You could, but I did not cover it with this anyway. You could use multiple. All right. So that's how we create the server. Already we covered that, right? So all sockets are created by using socket function, the socket function. Servers need to sit on a port and wait for requests, so they all must bind to a local address. They all must bind to a local address. The TCP server must listen for incoming connection. So that's what it doesn't do. Listen for the incoming connection. Once the setup process is complete, the server can start infinite loop. We already saw the infinite loop. Okay? And then when somebody tries to communicate, it has to accept. Okay? By default, accept is a blocking. That means the execution is suspended until connection arrives. All right. So to create a TCP server, once a connection is accepted, it's been an hour and a half.
Yeah.
Seriously?
Yeah.
7:35.
Okay. When the incoming request arrives, the new communication port create a new. That's what I was saying. Once the communication arrives, a new communication port is created to converse directly with the client, leaving the main port free to accept new client connections. That's what I say. So initially, everybody would connect with the main number, with the main port. After the connection happens, the communication, the conversation will happen with a new port. With a new port. I mean, I'll give you a break in a few seconds, but let me finish this, if you need to explain things very well, it's going to take you forever. If you need to go flip through slides, I could finish you don't know how you win, right? Anyways, so once the temporary socket is created, the communication can commence, and both client and server proceed to engage in dialogue of sending and receiving using this new socket. All right? Until the connection is terminated. Myself, I call it same socket, a new port. All right? If you like to call it a new socket, like not a new port, a new socket, call it whatever you want, right? Okay? But the point is, the first communication comes with the main port. All the clients will communicate with main port. Then there is a new port for each client. You want to call it a new socket, so the socket, the first socket, and then each client has their socket, that's fine. Call it like that. If you're going to call it a new port, myself, I look at it like a new port, okay? But if you need to call it a new socket, that's fine. Doesn't matter. Just understand the mechanism, how it works. So termination usually happens when one of the parties either closes its connection, there's a close function to close the connection, or sends an empty string. If the empty string happens, then it closes. That means for each new communication, what you have to do, establish a new connection. That's why we call it reliable, but that's why we call it slow. Right? Because every time I have to spend some time for the connection. Right? Connection, right? Alright, so this is a code in here. So this is a server, I think. Which application you want to use? Let's use this faster, maybe. Delete in here. I think I kept the code here. So in here, for example, let's select this code. All right, so in here, take a look at this in here. I'm sure you can see, right? I'm sure you cannot see. So let's go in here, and let's just keep this curved, okay? Now, can you see in here? Okay. So in here, what we did, from socket import all the clauses, and then time. So in this application, what we do, that whenever we send a message, so we're trying to create an application, okay, server, and the clients, right? Client, okay? So the client will send a message, for example, hello, and the server will print the timestamp when it was received. All right? We could have multiple, right? So let's take a look at the server section. What is the first thing we have? We have the host. It's a local, okay, whatever it is. Then the port is 21576, any port. Then the buffer size 1024. Then the address. What is the address? Built of two things, which is the address and the port. All right. So what is the first thing I have to do? I have to create the socket. So socket, I'm using internet and using stream, TCP. Simple. I don't have to include the third parameter, it's 0, default. Then after that, what I have to do, now I create a socket. What's the name of the socket? Tcp Server socket. You could give it any name, right? That's the name of the socket. Step number 2, what I have to do? Bind. So I took in here the socket in here, and I bind to it what? The address. Where is the address? Is in here. Is defined in here. Number 3, what I did? I made the server listen. 5, what does it mean 5?
5 seconds.
5 clients. So maximum for 5 clients. If you are connected to 5 clients and the 6th client try to connect, what will happen? Go away. Alright? Alright. Then after that, what we're going to have? 2 loops. Right? The steps, right? 2 loops. The first loop to accept the connection and the second loop to communicate, right? Right, guys? So, print waiting for connection. Okay, then TCP. Okay, and here what I did, the socket then accept. Accept. Alright? And we need to return the address. And we return what? The TCP client socket. Alright? Okay? Then the sub loop, what does it do? It will receive. It will receive the data from the client. Okay? And the maximum size is 1024 in here. If not data, if there is no data, if they send you an empty packet or empty message, what does it mean? Break. Close the connection. Otherwise, what you do, you send back the time it was received. That's the application. Let's run it. Run. Okay. Allow. Here. So what I did in here, now what's happening to the server? Listening. All right? Let me look at the client. Close this. Minimize this. All right? So this is the server. And this is the client code. Let's take a look at it. We'll give you a break. Okay, in here. So this is the client. Let's call it a client. Okay. And let's save it in downloads. Client, okay? the local
Yeah.
address. Okay, let's see, let me post it here. Let me say here. File. New. File. Why do you have to create a new project, seriously? Okay. Create, that's fine. Okay. Alright, so let's go file, new,
This is up.
I need to create a Python file, where to go?
So
Okay.
right click on the untitled folder,
Right click where?
untitled folder,
Here,
in the project.
Left hand side, Prabhu, on the left hand.
here,
New.
new. Something weird in here, file, new project, just a second, new project, let's select Python. Yeah, Python project. Okay. Create. Open in the current window. Now let's run it.
You need the
Start the
server,
server.
you need the server one.
I'm not sure what's the problem, just,
You need the server, file. Server code.
the server I already run with the different application in here. But you know, I could just a second. Control A, control copy. And let me go in here. Here, let me close this. Alright? And let's in here say
Left click.
new Python file. It's called server. Okay. Server. Okay, then Control V in here. If I need to execute the server, run the server.
Yep. Now it's good.
Allow access, no problem. Okay, waiting for connection. I have to go to the client and I should be able to run it. Okay, so that's what it is. So I need to send the client, I need to send a message, hello, for example. Hello, right? From the client to the server, right? Then I received it from the server. What did I receive from the server? The message with timestamp. That's the application, right? Okay, if I send another message, for example, hello, another hello, so that, okay, let's wait for hello now. You see, the timestamp has changed, right? And it's sent from where? From the server, all right? I could have multiple clients, you know, I could, for example, create another one in here. Okay, here. New. Python.
You can run the same
Client. 2. And Control V here. It's client 2, right?
No, that's.
This is maybe the server. This is the server. Okay, let me delete it in here. Let me go to client 1. Client 1 here. Control A, control copy. And go client 2, control V. And let's run client 2.
Shouldn't you change?
So now I have 2 clients are running, right?
Don't you change the address?
What?
Don't you have to change the address?
I bet it's where?
In a client. And the
The
client.
client, second client.
Otherwise it will be running the same.
Because I'm using the local host.
Local is in the software, but in a client there should be a different IP address because I'm from a different side and another from a different
No.
side.
The host in here in the client is the address of what?
Local,
Of the server. What's the address of the server?
the same.
Address of the service.
What's the address of the server?
Address of the device.
No. Address of the there is none. So this is the client, right? So what I'm saying, the host, 127.0.0 is what? The address of what? The server. I'm connected to the server. This is the port. The address, the port of what? Of the server. I need to connect to the server. How can I connect to it? I have to know its address, its port. So I hard coded it in here. Clear? I'm not sure why you're confused. I need to connect to the server. Okay? You need to communicate to me. How can I communicate to me? By knowing my name, right? I need to communicating with the server. So what is the address of the server? It's the local host. If the server is running in a different machine, then what I have to have? The IP address of that machine, right? And that's simple. So I'm connecting there. In the server, in here, in the server, what I'm doing in the server, okay, I'm not putting the, in here, I'm not, putting the host. I could put the local host, but if I make it empty, it will take the local host and the port number. So in both the programs, I'm putting the address of what? Of the server. Okay, of the server. I'm binding the address of the server. Okay? So 2 clients now are connected. They go from you send a message from the client to the server. The server sends you what? The timestamp. Alright? So in my example, the server and the clients running where? In the same machine. Okay? So your homework will be which is very simple. Okay, you need to work with your partner, that you're gonna run the server in one machine and run the clients in different machines. Is it tough? You have to put them in the same network, and you have to know the IP address. That's it. It's simple.
This is the project.
Yeah, this is a project for 2 minutes. For 2 minutes. All right? So let's have a break. Go. No, this is very simplistic, right? There is another module. Okay? Okay, let me go in here. All right. Anyways, the examples and the codes are there. You could try them by yourself. All right. Okay. Now I gave you another example how to create UDP server. What's UDP? Connectionless.
Connectionless server.
And I gave you the codes. You try them out. All you have to cut and paste. That's very easy. I'm gonna skip them now. Okay. These are the modules. Okay. So the socket is a very simple. There is something called another module. Okay. You know, in Python, it comes with modules, right? Okay, modules. So you know, like for example, last week you covered GUI. Okay. So there's 2 different. There's many GUI modules,
TK
right?
Inter and Kiwi. TK
Right?
Inter and Kiwi.
And Kiwi, right? That's with Kiwi. And there's
TK Inter.
TK, right? So different, all right? Same, different, and no. work differently, different functions. You prefer one over the other one. One is stronger for a certain application more than the other one, right? So socket is a simple one, which you have two examples I created for you there. But there is something called socket server module, okay? And it's a higher level module in a standard library than the standard library. Okay, it simplifies a lot of necessary creation for the codes, and there are several classes created for you, okay, in your behalf. So these are the modular classes. There's a few classes that you could use, okay. And I have created an example for you. Take a look at it, run it, just understand how it works, and this is the execution for it. Okay? So there's a module we covered in here. There's a module for experimental. You could try with it. The rest of the things is for your reading, so you don't have to worry about it. Anyways, so what we have covered today, network using socket programming. So we gave you a good background about, communication, socket programming. There is a module called socket, and there's another module called socket server. All right. Socket module has many methods, many attributes. You could use it in a certain way. The other one you could use in a different way. The first one is like methods based, function based. The second one, which I did not cover, but you'll read it, is classes based. There's a class, so you call it classes, you create the classes. I gave you examples, you have just to read it and go over it. Now, if, for example, for a reason, there is something you don't understand in the slides or in the material I provide, no problem. All what you have to do, there is something, huh? What?
I mean, if I have any question, I will email you.
That email me, that's always good. But what you have to do, there is something in any computer called Google. Okay, google.com. So google.com, okay, the module, okay, and Python 3. You'll see the whole manual with a lot of examples. Okay? All you have just to go through, and it's very well explained. By the way, Python is very well served. Very well served. Alright? And you try the examples and all and of course if you have questions, there's no question, you always could email and come to my office. Clear? So I was hoping to cover much more in this class, okay, but it seems like, I'm getting slower. Thank you so much, and you have a